pretty quick because we talked about it. Okay, so on page 12, remember that a rational, anytime you see the word rational in math, it just means a fraction. So you're going to graph your rational function. There is the formal definition. Don't worry, I'm not going to quiz or test you on that. So let's go ahead and remember that the vertical asymptotes are inputs that would just slow up the machine. So here on number 1, remember to find anything, you have to factor first. So let's practice finding the vertical asymptotes, and in order for me to find that, I have to factor. And again, this is x plus 1, x plus 2 on top, and underneath is x plus 2, x minus 1. So remember, we factor first, then we identify holes, because holes are not part of your vertical asymptotes. So again, remember, we had things that canceled out here. So if I am just looking at what the vertical asymptote is, you only have one. The vertical asymptotes are the stuff in the bottom that do not cancel. So the vertical asymptote for number 1, again, is just going to be x equals 1. So that's your vertical asymptote. Let's take a look at this next example. Yeah, now we're just breaking down each piece.
But for the vertical asymptote, there would just like a bottom.
Yeah.
And then the horizontal one would be
fine. Compare the degrees at the top and the bottom. So, guys, another way that you can remember what the vertical asymptote is, to me, that looks like a down arrow, and it reminds me to look down below the fraction mark. So remember, your vertical asymptotes are below the fraction mark. Okay, number 2. We're trying to identify the vertical asymptotes. We cannot do anything until it's completely factored. So once we completely factor this difference of squares, we have 2 vertical asymptotes here. What are they?
2.
Very good. So you're going to have 2 vertical lines on this one. You have to block out -2. It would make the denominator 0. You have to block out +2. It makes the denominator 0. Okay. 3, we factor. Let's go ahead and start factoring. So for number 3, your numerator is going to have numbers that multiply to a -3 but combine to make a +2. So it's going to be x plus 3 times x minus 1. And your denominator is already in factored form, so I'm just going to recopy it. So remember, holes take priority over vertical asymptotes. Clearly, we have a factor that cancels out. So we do have a hole, and I'm going to write there is a hole at x equals a -3 something. So when those cancel, our simplified expression is going to be y equals x minus 1. That's the only thing that's left over.
Wouldn't that make it a 0 instead of x minus 1? It wouldn't make it over 0 because you cancel them out.
No, but there's an x minus 1 left.
They all didn't cancel out. We have this.
Yeah, but what about the denominator? Would that be a 1 or 0?
It'd be a 1. Oh, yeah. When you cancel out everything at the bottom, that's a 1.
Oh, okay.
And remember, anything over 1 is just whatever it is. So I'm going to go ahead and erase that. Yeah. Yep, you're right. So look at my simplified version. I know I had a hole at the -3. Remember, you'd plug in a -3 here to get the y coordinate. What is the y coordinate of the hole?
3.
-3 minus 1? Okay, good.
Oh, you don't. Oh.
Remember, that's x minus 1. So -3 minus 1 for the hole. Remember, these canceled out. And we have a hole at -3 because if x equaled a -3, it would be undefined. And to figure out where that hole exists on the coordinate plane, you have to plug in the -3 to find the y coordinate. But guys, remember the question is asking about the vertical asymptotes. And vertical asymptotes always come from the x's in the denominator. Do you have an x in the denominator? And you do not have a vertical asymptote. So there is no vertical asymptotes here. None. Okay, let's move on to horizontal asymptotes.